Okay, so we're gonna be doing module two now, and module two is just talking about parameters, parameters of motion, right? Parameters of motion. Okay, so in this case now, I'm gonna just use this short video to just explain and give the formula of each parameter of motion. Then in the next video, that's module 2B. So let's say this is module 2A, 2A. So the next one of 2B, I will solving total of 12 questions across all the parameters. So now in this scenario now, the first parameter here we're dealing with today is distance. So let's just say distance and displacement. Now distance is just basically what is it called? The part or the space between two different positions. So just this is distance and without direction, right? Why displacement is distance with direction. That's just it. A distance that has direction, something like this. Do you understand now? I've explained this already. So I think with that being said now, distance now does not really have a formula. But if you're trying to derive the formula from speed, distance will be equals to what? Will be equals to speed. Speed can be represented as V or S multiplied by what? By time. That'll be the formula for distance. And yes, distance does not have what is it called? Does not have direction. So distance is a what? Is a scalar quantity. Is a scalar quantity. And the unit for distance is what? Is meters. That's all about distance. I hope you get. So I think now let's move to this number one. So let's move to number two, displacement. So displacement now is just the what is it called? The space between two objects with direction, between two bodies with direction. That's just it. So in that scenario now, the formula for displacement is just basically the final displacement. Let's use the displacement as y, or let's use x. Final displacement minus initial displacement, and that's it. So the in this case, displacement is a vector quantity because it has direction. It's a vector quantity. Displacement, the use for displacement is also meters. Now, ladies and gentlemen, displacement and distance are the same thing. Just like the distance between here and here, that's distance. The only difference between distance and displacement is just that one has direction. mm, Sorry, one does not have direction. One has direction. That is just it. So I don't know. I think let's go up. Hey, sorry. So the next one we're doing is this. So let's say this is one. This is the first set. So the second set is speed and velocity. Speed and velocity. In some books, they denote speed as S, and while in some they denote it as V. While velocity is V with an arrow showing that it has direction. And in some book also, velocity is also written as only V. So you can use these two symbols for it. I hope you get. So now let's talk about speed now. Number one, speed. Speed. The formula for speed is what is speed? Speed is just the what is it called? Distance covered per time. Speed is just distance covered per time, and per means divide. So it has distance over time. That's speed. And what's the speed is also a scalar quantity. And how? Because distance here is scalar, time here is scalar. So both of them is what? Scalar quantity. Sorry, scalar quantity. Now, what's the unit of speed? Since we have distance, which is meter, and we have time, which is seconds, so it's meter per seconds. That's the unit for speed. Now, for velocity, the formula for velocity, and what is velocity? Velocity is just basically what? Is just the displacement per time. That's just the difference. Displacement, is distance and displacement per what? Time. So remember that. How do we get scalar quantity? How do you know the quantity now? Displacement is vector, time is scalar. So which means what? Velocity is a vector quantity. Then for time, sorry, good evening. Then velocity is based over time. Sorry, that was a mistake. So what will be the unit? The same thing also. Unit for displacement is meter. Remember that. What is it? Meters, right? The unit for time is seconds. So that will be meter per second. I know you'll be surprised. Yes, speed and displacement, speed and velocity has almost all the same thing. The difference is just that one is using displacement, one is using distance. One is scalar, one is vector, but they have the same units. So speed and velocity are the same thing, totally the same thing. The only difference is just that what speed has no direction, velocity has direction. That's just the difference. That's just the difference. So with that being said, now let's touch the final one, which is acceleration. So acceleration now. Acceleration is represented with small letter A. Please don't make mistake with small letter A. Capital letter A is area. So small letter A is acceleration. What is if I want to define acceleration, how will you define it? Acceleration is just the change in velocity per time. Change in velocity. What does it mean? It means that what the final velocity minus the initial velocity, and I said what per time. Do you understand? It's just the final velocity attained by a moving object subtract minus the initial velocity attained by a moving object per or over time. So in a simple scenario, that's A is equals to what? V minus U over T. Yes, V is final velocity, U is initial velocity. So what will be the unit? Let's check it out together. That will be unit to be what? Let me use red pen. The unit for velocity is what? Meter per seconds. The unit for this one is what? Meter per seconds over time, which is what? Seconds also, right? So in that scenario now, what is it called? This M will cancel one M. But in this scenario, the reason why this M will not cancel this M is because initial velocity in this case is always zero. Because all objects start at rest. Meaning this how can I use this mic now at rest, initial velocity is zero. Is it moving? No. Initial velocity is zero. Then it starts moving. Let's say when it start moving, the final velocity will become let's say 10 meter per second. So yeah, the initial velocity is what? Is zero. When it starts moving, it becomes 10. So that will be just like saying, let me borrow this box, please. That will be 10 minus zero. Initial velocity is zero. Final velocity when it starts moving. At rest, initial velocity is zero. When it starts moving, the final velocity is 10. So 10 minus zero will give us what? 10. So in that scenario, we'll be having what? This one minus zero will remain meter per seconds over seconds. So equals to what? Meter over 2 seconds, which is second square. So the unit for acceleration is what? Is meter per second square or meter s minus 2. That is it. That is it. And then with that being said now, we can actually say the quantity of acceleration is what? Or what quantity is acceleration? It's a vector quantity. And that's it. We are done.